Good day. We're going to discuss the JFET self-bias configuration. So this is the self-bias configuration consisting of three resistors RD, RG, and R sub S. So unlike the fixed bias configuration, so there's a additional voltage source in the gate terminal. That's the disadvantage of the fixed bias, the additional gate source. But instead of using if you remove the gate source, so you're gonna add the RS. So this is now the self bias configuration. So RD, RG, and RS. So like the fixed bias configuration, we're gonna compute the VDS, the output voltage, the output current, ID and IS, and as we all know that IG is approximately equal to 0, so the input voltage is equal to VGS. So since ID is approximately equal to IS, and in order to calculate ID, we're gonna use the Shockley's equation, which is equal to 1 plus VGS over VP squared. So another is voltage here is VS, voltage here is V sub D. So we're gonna compute VGS, VDS, and the drain current in order to calculate the important parameters, so the input current, input voltage, and the output voltage, as well as the output current. So let's start first with the VGS. VGS. So same with the fixed bias configuration, we want to short CRG. So if we short at CRG, mag-ibel tadari. So therefore VGS, so this is plus minus, so this is plus minus, this is plus, VS equal to 0, so VGS plus, so VS is equal to IS RS equal to 0, so therefore VGS is equal to negative IS RS. So since IS is equal to ID, so therefore VGS is equal to negative ID RS. And then we can also use the Shockley's equation, 1 plus VGS over VP squared. What else? VS is equal to ID RS. So these are some helpful formulas. How about VDS? So VDS, mag-loop ta dere, this is just equal to VDD minus IDRD minus VDS minus IDRS equal to 0. So therefore VDS is equal to VDD minus ID times RD plus RS. So this is the formula, or pwede po VDS is equal to, so VDS is equal to VD minus BS, where VD is equal to, so as you can see, VD is just equal to VDS plus BS, so you can use also this formula, VDS minus BS, where VD is just equal to VDD minus ID RD. So you can use also this formula. So let's have an example. So let's have an example. Determine the following: A, VGS, ID, VDS, BS, VG, and VD. This is the network circuit diagram where RD is equal to 3.3K, R is 1K, 1 mega ohm, RG, ID says is 8 milliamps, VP is equal to negative 6. So which one is gonna be first? So first let's solve A. So VGSQ is, as you can see, VGSQ is equal to negative ID RS. So therefore this is 1000 ID. So since variable po man wala po na solve. So let's name this one equation 1. So for ID Q is equal to, so this is 8 milliamps times 1 plus minus VGS over VP is 6. So plus na squared, negative man na, negative 6, then minus man eh, so therefore this is plus. So since IDQ as well as VGSQ are both variables, so they are not, they don't have any known values yet, so this will be equation 2, no? So we'll substitute equation 1 to equation 2, no? In terms of VGSQ. So therefore in terms of ID from equation 1, so this will be VGSQ divided by 1000. Substitute nato ni siya, wala. So therefore this will be VGSQ divided by 1000, so 8 milliamps times, so you're going to expound this 1 plus VGSQ over 6. So expound na to ni. So this will be VGSQ squared divided by 36 plus 2 VGSQ divide 6 plus 1 so therefore VGSQ with 1000 go to 8 milliamps. So this will be VGSQ squared plus, so this is VGSQ over 2 plus 1. So this is well, so by the way, so whether did I get this one, so you're gonna use your algebra, your FOIL method or the special product in order to come up with this one. So in this case I use the FOIL method where so for example 1 plus VGS over 6, 1 plus VGS over 6. No, you're gonna use FOIL method or special product if you master the art of algebra. So this is 1 times 1, this is 1 plus 1 times VGS over 6, then VGS over 6, then times ni VGS squared over 6. That's it. Oh, this is VGS over 36, VGS squared over 36, this one, then duha, you add them up, so this is 2 VGSQ over 6, then the 1. That's how I come up with this values. Then you distribute 8 milliamps. You can either distribute this one or you multiply this one with 1000. So VGSQ multiply 8 milliamps to 1000, so that would be equal to 8. So VGS squared over 36 plus VGSQ over 3 plus 1. Distribute So 8 over 36, 8 over 36 is, oh, so you use a whole number. Don't use a factor. Don't factor this one, huh? The whole number lang siya. So with 3 decimal places, g squared plus 80 by 3, 2.67 VGSQ plus 8. And then this term will be transferred to the right side. So 0 is equal to 0.222 GSQ squared plus, so I think minus 1 is 1.67 GSQ plus 8. And then you can use your calculator, no, to find the value of, so since this is quadratic, no, so you're going to have two values of VGS1 and VGS2. So you're gonna use your calculator. So in using your calculator, so you're gonna use mode, then 5. So you're gonna use the quadratic number 3 and enter the values. This one 0.222 and then 1.67. so it should be in this form, then 8 ang C, and then that's it. So ayun. So by the way, there's an error in this equation. We forgot the negative value. So it should be negative, and this will be also negative. So negative na. So if negative na, so this will be plus siya dali, so this will be 3.67. So that's it. That is 3.67. So let's start again. So mode 5, 3, so this is 0.22, 3.67, and then 8. So these are the values of VGS, negative 2.58. 2.58 volts, and the other one is negative 13.95. So we have two values of VGS1. So in your solution, in our quizzes and examples and also exams, so you're going to show this solution. So there's no shortcuts allowed. So you need to show the solution up to this quadratic equation. So when you're in this quadratic equation, you are allowed to use your calculator na in order to find the two values of VGS. So we've come up with these values, negative 2.58 and negative 13.95, which is the correct answer. So the answer should be, so if you look at the pinch of voltage, negative 6 volts, it should be lower than this magnitude ani, mas gamay sa magnitude, which is 6. So the value that is lower is VGS1, which is negative 2.58. Dili siya pwede mulapas aning 6 na magnitude, no? So therefore the correct answer is negative 2.58, no? So therefore VGSQ nato is negative 2.58 volts, and ID is D. ID is equal to, pwede na ito magamit na yung formula, no? IDQ is equal to negative, then negative 2.58 divided by 1000. So IDQ is equal to, ilan man eh? So this is 2.58 divide 1000. I think that's 2 milli, 2.5 milliamps. So this is 2.58 milliamps. So don't forget the unit, it's very important. How about letter C, VDS? Formulas VDS. So VDS is equal to, so the back side, diba, no? Ano nga formula where it is equal to, VDS is equal to VDD minus ID plus RD plus RS. So this is 20 minus 2.58 milliamps times RD is 3.3 kilo ohms plus RS is 1 kilo ohm. So therefore, dito na, calcio 20 minus 2.58 times 3.3k plus 1k. So it's equal to 8.906 volts. VDS na. So how about VS? 30. VS is equal to ID RS. So this is 2.58 milliamps times 1k. So VS is equal to 2.58 volts. So pilain VG. VG. How about VG? So from the formula, VGS is equal to VG minus VS. No, VG is equal to VGS plus VS. So therefore, VGS is negative 2.58 plus 2.58. So therefore, this is equal to, VG is equal to 0. Next, BD. BF. BD is equal to, that is equal to, BDS is equal to BD minus BS. So therefore, BD is equal to BDS plus BS. So BDS is 8.906 plus 2.58. So BD is equal to 8.906 plus 2.58, 11.486 volts. So that's it. We have now the values, VGSQ, this one, ID, VDS, VS, VG, as well as VD.